with no camera or anything and just teach the class like a traditional class. And if you miss, you miss, right? The other option is this, which is a camera which is only gonna record between here and here, okay? And I'll just post that video on YouTube later. And at least you'll get anything I write down. If I work problems out, you'll see it, right? Anything I say, you'll hear it. So that's the second option. The third option is I have this, what is it? Like a tripod, but it's a big heavy duty one. I got like this whole setup where I can write on my screen and have my laptop, and it's basically a Zoom class where everything's being projected from the projector onto this. But the thing I don't like about it is I just stand behind the thing. And it's just like it's Zoom, except you're sitting here and you're watching the screen. And so I wanted to do this. If you're happy with this, if you're okay with this, we'll stick with this. If you feel like you'd prefer to see the other way, I'll ask you later, maybe next week. And if y'all want to see the other version of it, we can do that too. All right, let's get down to business. So did y'all bring stuff to write with? Yes, pencils, paper. All right, we only have, what, hour and 15 minutes in this class? So look, we didn't have class, right? We didn't have class on, what was it, Wednesday, right? Was it Wednesday? Yeah, Wednesday was when we had the, right? Thursday, sorry. Thursday, right? So this is where we left off. We were solving linear equations. And so I put the steps up here for us, and that's what we're gonna continue that today, and then we're gonna move into the next few sections, and then I'll tell you at the end what homework to look at out of the packet, all right? So there are some problems for solving linear equations that we still need to do. So I wanted to start, just to kind of get us going, I wanted to start with something that we haven't done. It's similar to something we've seen. Ooh, this marker's no good. Just let me know if you can't see this. Let's see, x minus 1. Okay. All right, so this is a linear equation. This is going to look a little bit different than things we've seen in the past because of that parentheses up top. Let me see. I'm going to guess... Alice, what's your name? Allison? Okay, that's what I was going to guess. All right. I had a 50-50 shot on that. Okay, so here's a linear equation, right? So we have the equation. It's linear because you see x's raised to the first power, right? Nowhere do you see a squared, cubed, or anything like that, right? So we're going to just follow the steps. First thing is to make sure it's a linear equation. It is, right? So first step, good. Next, we're going to clear fractions or decimals. Now, we see fraction, right? We see this fraction here. So we need to clear this, which means we need to get rid of this 3. Since this is the only denominator we see, there's no other denominators anywhere, this is the only thing I need to worry about. And since this is a 3, I need to multiply both sides by 3. Okay, now this is the part that's a little tricky. Because when you say multiply by 3, right, 3 on this side, and on this side, multiply this by 3, I'm going to put it here. The thing that's tricky is this. On the right side, because there's 2 terms, the 3 will have to pass through, right? So that'll just become your, what, 3x minus 3, right? But the left side's the part that's a little bit tricky. And it just depends on how you do it. Because this is in this x minus 2 is in parentheses, you could distribute the 3 through. You could do that, all right? But the better option is to just cancel the 3's, all right? And then there's no distribution required. Do you understand why that cancels? Right? Because that's like a 3 over 1 common factor. You cancel it out. Yes? Yes. Okay. So we have x minus 2 is the only thing left on this side. And I do not need to write it in parentheses because it's the only thing left over here. Okay? So we have cleared fractions. Now I'll clear any parentheses. I don't see any parentheses. I'm going to combine like terms. So on the left side, no like terms, right? Can't combine these. Can't combine anything over here. So now we move on to isolating the variable. So you get to choose which side you want the variable on. Just for fun, I'm going to move it to the left. All right? That's what I'm going to choose to do. So to do that, I don't have a bunch of fancy colors. I guess I could use other markers. I'm going to get rid of the 3x, subtract 3x, subtract 3x. That'll get rid of this. And then I'm going to want to move this -2 to this side, so I'll add 2 to both sides at the same time. So that'll go away here. So let's see. I'm going to have to learn your names, and I'm not good at that. So Allison, since you came in, why don't we ask you? Where are you? Allison, how you doing? Allison, sorry. So what do we get on the left side, Allison? Minus 2x. Okay, good. And then on the right side, Allison, you have -3. You're going to add 2, right? Think of it like money. -1. Good. Okay, and now we have isolated the variable. And last step is to make sure there's a 1 in front, right? A 1 in front. So let's go. I'm just going to go alphabetical. How about Kylie? Kylie C. Divide by -2, right? Divide by -2, divide by -2. Gone here, so we should get a final result. X is, what is that, Kylie? 1/2, right? Because there's 2 negatives, right? So we get x is 1/2. All right, that was just to get us kind of going again. This all look familiar? Yes? Okay, let's look at another one. Yeah, this one too. This one, I like this one because it's just got some weird stuff in it. This almost feels like archaic to be doing markers on a board. Okay, 4 minus 1/3 parentheses 2 minus 7x parenthesis equals 2, and then x minus 1. All right, so we're going to solve this linear equation. It is linear, right? Equation, x to the first power, x to the first power. All right, clear fractions and decimals. See any fractions or decimals? Yes? So you see that 1/3, right? That's the only fraction we have. So how are we going to clear this? How are we going to clear this out of here? What do we have to do?
Multiply by 3.
Multiply by 3. Everything, right? Both sides of the equation. Okay? Both sides of the equation. So we have to do the entire left side by 3 and the entire right side by 3. Let me try one of these red ones, see if they work. So I'm going to do the entire left side by 3 and then the entire right side by 3. Okay, so this is where I think people kind of get a little hung up here. So let's see. How about we move on to the other Kylie now? So what happens over here with this 3? We have to multiply it through. So it has to distribute, right? So I first distribute it. The 3 has to go to the 4, yes? Okay, which will give us? I'm sorry? 12. Okay, now here's the part, Kylie, that I think is tricky. This 3 has to come and do something to this, right? So Kylie, do I multiply the 3 times the 1/3 and to the parentheses both? Like, does the 3 hit all of these, or does it hit just one of them? You know what I'm saying? Are you unsure about it? Not sure, right? It's a little confusing. That's why I want us to do this problem. So let's, what do you think? Sir, what's your name again? Garrett? Garrett or Jarrett?
It's Garrett.
Garrett, okay. So say?
All of them.
You think all of them, okay? So you think it's going to go here and then here, oh, sorry, to the 2 and then to this one?
Well, are we multiplying it by 3 to cancel the fraction?
We are going to cancel fractions. So this 3 will go here and cancel, but do I still need to do the 3 through to those 2? Yes? Unsure, right? Kylie said unsure. Anyone else have a thought here? See, this is why I wanted to give you this problem. This is the little things that mess people up, right? These little things. So before I do it, let me just ask you something. If I ask you to multiply 3 things together, 3 times 4 times 5. When you multiply three things together, do you distribute the 3 to the 4 and then to the 5? Do you do that? Or do you just do the 3 and the 4 together first, and then that answer times the 5? You know what I'm saying? Like, is it 3 times 4 is 12, and then times 5? And then that gives you 60? Is it that? Or is it 3 times 4, which is 12, times 3 times 5, which is 15? Does that make sense, the two different things I'm doing here? One of them is like a distribution of the 3 to both of them. The other one is group those, put them together, multiply, and then the 5 times that answer. You'll see you're going to get two different answers. So the question is, which one is it, right? Which one is it? It's this one, okay? You never distribute multiplication through multiplication. You only distribute if this is like 3 times, and then if we had 4 plus 5, then you could distribute the 3 through to both. That's called distribution over addition. But what you need to know is 3 things multiplied together, first 2 together, and then whatever that answer is times the third thing. So when you look at this multiplication of this 3 through, right, when we do this 3 through like this, I want you to look at it like we're really doing this. We're really doing this. We're doing 3 times a third times the 2 minus 7x. Do y'all see that that's what's really happening there? The 3 is multiplying times these two things, but these two things are being multiplied. So you're really doing 3 things together, you see? So we're only going to put these 2 together. Now these cancel and just give you a 1, right? And then this is all that's left. So see, it doesn't distribute. It does not go through to these. All right, Kylie, that makes sense? Any questions on that? Allison, you got that? Okay. So this to here, just the 1/3 and the 3 cancel, which leaves me with a minus, right? And then I still have this. And I need it in parentheses still. The reason I need it in parentheses is because there's a minus. So I'm going to subtract both of those, so that minus sign is going to have to get passed through. Are there questions? What about this side then? Let me go to, let's see, Garrett just talked. Alexis, did Alexis show up? No? Okay, Raymond, you get this side.
Okay.
So what do you think with this 3 here?
I think you're going to hit the 2 with it first.
Hit the 2, right? And that's it, right? You're not going to pass the 3 through this one. Same thing, right? These two things are being multiplied, and then you're multiplying a third thing. So that 3 hits the 2 and the 2 only, and it's it. You're done. So it'll become what, Raymond?
It'll be 6
And then
parentheses of x minus 1.
still got to leave it in parentheses, right? Okay, I hope that's clear, everyone. 'Cause these are the little subtleties in algebra that if you don't understand them, makes it really hard, right? Okay, let's continue. We have cleared the fractions. Now we're going to clear the parentheses. And Corwin, you want to do that for us?
You distribute the minus sign and the 2 and the 7.
Yeah, so you're going to just distribute. You could almost look at like a -1, right? And just kind of like pass it through. So just, what would you have, Corwin, on the left side?
12 minus 2 plus 7x.
Plus 7x, good. It changes the signs. And then go ahead and do that side. 6x minus 6, same thing, distribution. Okay. You want to keep going, Corwin? What do we do next? Cleared, combine, right?
12 minus 2 would be 10.
These two can come together. That's 10 plus 7x equals 6x minus 6. I wanted to tell y'all something before we go any further. So this whole COVID thing has messed us all up, right? We've had to adjust our lives. I am officially in the worst shape of my life right now. I am in the worst shape of my life. So I have a goal by the end of this semester to lose 15 pounds. Now I only have 12 freaking weeks left. So it's going to be a tough, let's make it 12 pounds. Just, if I can reach that goal of 12 pounds, I'm going to give everyone here 5 points on the final. Okay? So y'all need to hold me accountable now. Okay, when we come in every week, I want you to make sure that I did my shit, because that's my goal. I used to be very, very, very active and healthy in triathlons, and then life happens. You get married and have kids, and things change. So, but anyway, so my goal, I started yesterday, and I'm going to go for it. Eating healthy, exercising. So, yes, sir.
You get a free 5 points every time you lose one.
Well, it looks like I'm eating Whataburger. Yes, ma'am.
I was actually going to say, so are you going to be keeping track of your calories and working out and
Yes.
showing us a food diary? So you can
Oh, you want to see a food diary?
and I want you to count out all the calories.
Oh, I'm counting my calories. I am doing that. I'm using MyFitnessPal. It's an app, and when.
Healthy calories, though.
Yeah, I understand. I know. Thank you. You can stay on top. I will keep a diary. I will keep actually I'll graph my weight and calories in, calories out. I do it on an Excel spreadsheet. So I know my trend, like how much I can lose per day.
Are you going to put it on Canvas?
I'll give you all a summary. I'm not going to do it every day. I'll give you like every 2 weeks I'll give you an update.
Just put an update on Canvas.
Yeah.
Announcement.
All right. Okay, so we've combined like terms, right? I wanted to tell you all that because I wanted to hold myself accountable. If I don't tell you that, then, yeah. Okay, here we go. Combine like terms, and now isolate the variable. So let's take the x's to the left. So how do we do that? Let's see. Cambry. Yes, right? I didn't call on you yet.
No, you haven't.
Okay, go ahead, Cambry. How would you just finish this off?
I would minus 6x on both sides.
Okay. Now, when you do it, Cambry, would you go ahead and take care of the number right now also, or would you just do that on another step? I'm just for you.
I would probably just take care of the number as well.
Okay, so what would you do for the number?
Minus the 10.
Minus 10. So since we're getting rid of the x's here, we want the x's over here, you don't want the 10 here, so you subtract it. And then there. Okay, so what do you have?
You have x equals -16.
Negative 16. There we go. Good. Okay, that makes sense to everyone? I thought one of my classes, I think in one of my classes, one of my students is a fitness trainer. It's not in here, is it? Okay. I have yet to tell them. I'm sure he's gonna be like, you want to see my details. All right, here we go. Let's do something different. Hey, how's it going?
Good.
Good. You found it. You Sarah? All right, Sarah. Welcome, welcome. We're doing some solving of linear equations, Sarah. And it's been fun. You can just tell by everyone's faces. All right, here we go. So we have not done one of these. They're not that bad, but what if we had 3.54x minus 2.1 equals 5 parentheses 2.4x plus 3.16. This is a linear equation, right? You have an equal sign. You've got x's in here raised to the first power, right? So we've got a linear equation. Second step, clear fractions and decimals. We have decimals this time, right? So first time we've had decimals. So to clear decimals, there's all sorts of ways to think about this, but what you do is you look at the numbers, you look at these decimals, and you look at how many digits you have to the right of the decimals. So here I have 0.54, so I have 2 digits to the right. Here I have only 1. Here, how many digits are to the right of this decimal, of the 5? There's none, right? Okay, so we have 2 digits, 1 digit, no digits, 1 digit, 2 digits, right? 2 digits. So what that means, since there's 2 digits, is that I have to multiply both sides of this by 100. If I had 1 digit, I would multiply by 10. If it was 3 digits, 1,000. Does that make sense? it's basically what it's gonna do is it's gonna move the decimal point to the right 2 places. That's what multiplying by 100 would do. So we're gonna do the same story. We're gonna take the whole left side, multiplied by 100, the whole right side, multiplied by 100. Again, two decimal places was the most we saw, so I need a number with 2 zeros, 100, okay? All right, same thing. So let's distribute through here. And now we may need a calculator for this, all right? Maybe not at this step, but maybe as we move on, you might need a calculator. So let's call on our next victim. Sarah, I'll come back to you, give you some time to warm up. See, Keegan? I didn't call Keegan yet, right? Okay. Keegan, what do you got there on the left side?
354x
354x?
minus 210.
210, yeah. So what happens is this moves 2 places to the right, so you get a 0 in there, 210. This, Keegan, is the part I'm really curious about how you're going to do. So how would you do that? How would Keegan handle that right side?
Just multiply the 5 by 100.
You could do the 5 times the 100, right? But that's all you can do, right? Because again, like before, this is something times something, so we have 2 things multiplied, and then a third thing. So the 100 can only hit one of them. So you said hit the 5, so it becomes 500. And then you still have 2.4x plus 3.16, right? So we have not removed the decimals completely, but we can pass the 500 through now, and that will remove these decimals, all right? By the way, just FYI, okay, when you hit this 100 on the 5, you could have done the 100 in here and left the 5 alone. It would work both ways, but I'm going to do it this way. 100 times 5 goes here, and then pass it through. So now I need someone with a calculator to tell me, just to be safe. Okay, so 500 times 2.4, anyone got that yet? Is 1200 even? So 1200x, that's this to here, and then here to here? 1580. All right, there we go. We have removed the decimals, right? We no longer have decimals. And now we continue, right? So parentheses, we don't have any. Combined like terms, nope, no like terms. Let's get all the x's to one side. So let's give somebody an option here. Abigail? Where are you at? There, Abigail. Okay, Abigail, what would you do here? Which way would you move the x's? It's kind of up to you, so.
I'd probably do 354 first, so I might subtract it.
Subtract 354x on both sides. Okay, and then we'll do that here. And that'll go away here. Would you like to deal with the number now or do it next?
I'm going to do it right now.
Do it now? So what would you do?
So then you would minus the
1580, good. So part of the reason why I like to call on you in class and make you participate, well, first, hopefully it makes it not so dry and boring, but also when I call on you, I get an idea of what you understand and what you don't understand. And that way, when you get to the test, if you don't do well in the test, like you've already proven in the class you understand that maybe you just had a bad day or the test anxiety or something. There's a lot less at stake here when we're just, going around the room. Okay. So someone give me the left side.
1790.
Negative 1790. And then what about this?
846x.
846x. All right. One more step. Got to get this x by itself, so we'll divide both sides by 8640. So I'll do that right here. Negative 1790, divide that by 846. And then I take the 846x, divide by the 846, and whatever that is. Go ahead and give me the decimal. Since the original problem had decimals in it, let's just make our answer a decimal. Yeah, just round it 2 decimal places. How about that? 2.10 or 2.12 is 12. Okay. And whenever we round, we usually put a squiggly equal sign, and that's actually a mathematical symbol. It means approximately. Okay, so we're saying x is approximately negative 2.12. Okay. So that's it. I think we are done with linear equations. What do you think? Let's wait on that. Let's move on to the next thing. We are behind in this class. I mean, there's just like no way to get around that. We are behind. But I'm not gonna rush. All right. So we need to now make sure, before I move into the next topic, make sure you understand what like terms are. And I think you already do, but I just want to make sure you do. So when we talk about like terms, like terms, the question is, what do we mean? Well, first of all, what's a term? Anytime you have a bunch of stuff being added or subtracted, and it really doesn't matter if these are pluses or minuses, just either plus or minus, plus or minus, plus or minus. If you have a bunch of stuff added or subtracted together, each one of these is called a term. Okay? Each one of them is called a term. So terms are separated by pluses and minuses. That's what terms are called. That's not the same as this. If I have something times something times something, do you know what we call these? These are not called terms anymore because there's multiplications in between them. Do you all know what they're called? They're called factors. Factors. Same thing here, factors, right? So I'll just give you an example underneath. If I wrote something like 2x plus 3x squared minus 4 plus y, okay? Then if you look at this, this is 4 terms, right? Over here, if I wrote 4x squared y, like that, 4x squared y, this is implied multiplication. 4 times x squared times y. Each one of these is a factor. Each one of these is a term. Understand the difference? Like just language-wise, yes? So what are like terms? Like terms are terms that have the same variables raised to the exact same power. Okay, so to be like terms, this is terms with the same variables, meaning the same letters. Okay, they must contain the same letters. So if one of them has an x and a y, the other one would also have to have an x and a y. But not only the same variables, those variables must be raised to the same powers. So let me give you, I'm going to give you some things, and you're going to tell me whether or not these are like terms or not. Right? So you're just going to give me a quick yes or no on this. So if I write 3x squared, and I write negative 5x squared, these are like terms, right?
Yes.
Because they both have the same variable raised to the same power. So check. Now if I write 3x squared y, and I write, I'm going to do a different number. I could use 3, but I'm going to use, how about just x squared y squared. This would not be like terms, right? Same letters, but this one's squared, that one's not. So this would not be. Is this okay? Okay, so when it comes to terms that are like terms, how do we add and subtract them? How do we add and subtract like terms? If you were going to try and explain that to like a 8-year-old, right? How do we add or subtract like terms. So let me take those. You said they were like terms. If I do 3x squared minus 5x squared, right? You just told me that those were like terms, right? And I'm trying to subtract them. What is it that we're doing? Like if you had to explain to somebody what this becomes, what are you actually doing here? Subtracting what? The 3 and the 5. All you're really doing here is taking that 3 and subtracting the 5. Right? That's all you're doing. You're doing 3 take away 5, which is negative 2. And then you're just keeping the variable, right? That's all you're doing. So for all like terms, this is how we add and subtract. You add or subtract the numbers in front. Okay? These numbers in front, you know what these numbers are called. More language here. This right here and this right here are called coefficients. Now, the only reason I'm telling you that is because if you were to say, hey, how do you add and subtract like terms? How do you do that? Then your answer would be, oh, just add or subtract the coefficients, right? The numbers out front. And of course, you keep the variable. Variables. Right, so that's what I did here. I was trying to add or subtract two like terms. So all I did was in this case, subtracted the two coefficients, got negative 2, and then I just kept the variable. I realize a lot of you know how to do that. I want to make sure we're all on the same page here. Any questions? Okay, so now let's do what is going to be in the homework. May I erase? Remember, this is all going to be recorded and posted on YouTube later, so instead of watching the Super Bowl this weekend, you can just watch this. You can get your family and friends together and, yeah, no? Doesn't sound good? 3a plus 2a squared plus 3a cubed minus a plus 2a squared minus 3a cubed. All right, so let me tell you what I want you to do here. I want you to simplify this. That means that's a big and ugly thing. I want you to see if you can make it look a little bit more condensed and nicer, all right? So I'm using in here the letter A instead of X.